here's the same spreadsheet. I just changed a few things to make it clear what we're going to do. This is for at least 2 out of each of the 3 of you. One person out of each of the 3 of you has been selected for a higher calling. I'll get to that in just a minute. All right, so the first 3 columns I've plotted, and then these additional 2 columns. This black line here, notice there are no arrows here, okay? This one with black diamonds is the input curve. And it steps from 90 to 95. I can observe that right here, right? And this chartreuse one. Chartreuse. Nice. Thank you. Go back. Pink, chartreuse, what would you call this? Fuchsia. Pink, fuchsia, chartreuse. This
Chartreuse
one.
is a green.
Pardon?
Chartreuse is a green.
Truth.
This one is the data. That's column C. Good enough. And then I have a model here that has yellow triangles. That's column D. And I have another one here that's this open things here, this sort of blue-green, that's called column E. Now, is that a big mess or what?
It's a big mess, Dr. Henry.
Who said big mess over here? Only?
Need some arrows.
What's the circle for? The circle is the area in which I want the model equations, which are columns B and E, to agree with the experimental data, which is columns B and C. And here's the procedure in which to do it. There's 7 or 8 steps here. Change that. This says the input baseline is 89. Did you notice that I told you earlier it was 90?
There's no arrows.
There's no arrows. This one is the input curve. The dark blue diamonds. These are the modeling parameters. The real experiment had the input of 90. And what's the model say? How can we get the model to agree with the real experiment? Add 1 to that 89? Let's see what happens.
Not quite.
Look. Go away. The yellow line is now at 90, which is what the experimental data was. So I've done number 1. Everybody say, nice.
Nice.
Number 2, make this number, that's the time at which the step occurs, T sub D, make this agree with when the step occurs. Well, the step occurred at 30, and the model says it was 31. What can we do? Change
For-
31 to 30.
Fixaroo.
Let's see if I can do that. Hot dog. It did it. Yeah, number 3. That's the amplitude of the step. Make this agree with the height of the step. The step went from 90 up to 95, and that's 5, right?
Yes.
95 minus 90 is
5.
good. And this says 4, so what should I do?
Add one.
It's just 5. Oh boy, I'm cooking the gas now, as he used to say. Now, look, the yellow one is directly on top of the dark blue. So the input model agrees exactly with the input experiment. That's what we're trying to go for. There's no question about that being an agreement, because it's just a step from one value to another. All right, next, output baseline. That's this white, green, blue here. And it's supposed to agree with this. Let me see, the axis is on the other side. Let me pull that over so you can see that. Notice when I say go away, things usually go away. Thought I made that smaller. Well, there you go, that's what it was. Now, your computer at home wouldn't be that slow, would it?
Probably not.
Probably not. All right, so this is the output, this red, pinkish, purple fuchsia. Looks like it ought to be about 79 ballpark. If I put my mouse over that, I could tell exactly what I want it to be, couldn't I, David? I could know approximately. So let me try that, see what happens. 79.123. Right? That's the time and that's the value.
That's right, Dr. Henry.
So let me write 79.1 in this place right here. Output baseline. What happened?
Madness.
It's right on top of the data. Model's right on top of the data. Next, K. Adjust the K, the gain, so the model agrees with the final steady state value. Here's the final steady state value over here. And I'm going to change K so that that is in agreement with that. Do I need to increase K or decrease K? Let me say increase. Raise your hand. 1, 2, 3. Wrong, because the model is higher. So in decrease K. You with me? Yeah, you knew that, didn't you? So I'm going to decrease K. K is now 2. I'm going to decrease it to 1. See what happens. Oh, too much. Between 1 and 2. Pick a number. 1.7. 1.7? You like that? How many want it to be any better than that? Why am I looking at the two Davids over there?
They're answering you.
Pardon?
They're answering you. Because they're answering you.
Oh, no, because they are obsessive compulsive sometimes. Particularly when it comes to Excel. So I put 1.7, that's two significant digits. Can I put another?
Absolutely not.
Okay, next, adjust this, that's the T0, the dead time, so that the model agrees with the initial changing in the output. The model is this one. The initial changing in the output is sooner than that, so what do I need to do to T0, dead time?
Make it 0.
Decrease it? It's already 0.1, let's make it 0.05. Well, it's going in the right direction, isn't it?
0.2.
0.03? 0.03.
Yeah.
0.02? One more?
That'd be a David demand.
If you didn't have Excel, wouldn't this be a lot more fun?
No.
Absolutely.
All right. So now, it agrees in here. Now the last one, adjust tab, so that the model agrees with the upper half of the changing in the blah, blah, blah. This is where I want to get the light blue, green to agree as much as possible with the pink, chartreuse, fuchsia violet. This is going to be the hardest one. What's going to do, increase it or decrease it?
Increase.
Decrease? How many say decrease? How many say increase? Increase it?
Sure.
Okay, I'm going to double it. Better?
That's what we not really good.
At least better.
Let's leave it.
It's a little bit closer here and here, but look down here. John? What do you think I ought to do now?
I have no idea. Go halfway between.
Halfway between 0.1 and 0.2? Well, we'll try that. That's 0.15, am I right?
Make the chart smaller.
Yes, ma'am? Say it again.